Thank you all for joining me and discussing your project. Could you please tell me a bit more about your background?
I'm an international student at Franklin and Marshall College in Pennsylvania. I'm currently a senior doing physics and computer science. And in my previous summer, I was doing a lot of robotic stuff for my summer internship. And then I came to the college and I also was doing robotics. Like I built my own drone and I also built like a unmanned surface vessel. So I really wanted to go to robotics. And I was just exploring for different opportunities, and I found this opportunity from Space Science and Engineering Center about building this STELLA device. And for me, my goal was to just develop more skills into like 3D printing, 3D modeling, soldering, also programming of microcontrollers, as I'm also a CS major, and that's how was my path.
Next, how about Alexa?
Yeah, so I am from Wisconsin. I am a mechanical engineering major with a certificate in computer science at UW-Madison. I have a lot of experience building my own things and building projects. I've loved anything I can get my hands on. So I've like built a small robot, I've done Legos, everything that I could possibly do. And then on top of that, I've had a lot of 3D printing, both in class and out of class. So when I found this internship, I thought it sounded great because there are just so many skills that I could apply. I could do the hands-on of the actual building of the spectrometer. I could do coding with my CS, and then on top of that, I could actually take measurements and analyze them. So yeah.
So I typically do research at Space Science and Engineering Center. I got my master's degree there and then was lucky enough to stay on as a full-time researcher. I love doing research, but sometimes looking at a computer screen for so long can get a little tiring. So I decided to take on some outreach tasks. So that's how I started teaching this STEM class in collaboration with the Greater University of Wisconsin-Madison. So they have a program called pre-college programs where they basically prepare K through 12 students for the college experience. My group was working with high schoolers from all around the world, actually. We had students from as far as Kazakhstan to here in Madison, and I taught a 2-week STEM class. So that covers everything STEM, and I thought it would be a great opportunity to test out our newly bought STELLA spectrometers. So SSEC had hired 2 undergraduate engineering students who came and ordered all the STELLA parts, put them together, did testing with them, and then in collaboration with me, we kind of came up with this short little curriculum that lasted maybe 1.5 to 2 hours in the classroom with our high school students, where we did a little hands-on lab with the instruments, and the students got to actually test them out. So that was really fun. I had gone over some basics of remote sensing with them beforehand. So just basics of like, what is the electromagnetic spectrum and how, things can give off different wavelengths and energies depending on what they consist of. So we tested out the STELLA spectrometers in class with the high schoolers. The class was 13 students, and they had a really good time getting some hands-on experience with the instruments.
Last but not least, Dr. Sam.
My background is really, I'll start with when I got involved in remote sensing, which was at Michigan State University in the year 1999, actually. And I got interested in Landsat then, and I was working with the Tropical Rainforest Information Center that had a huge Landsat archive. And so I got involved in kind of managing the archive, working with Dave Skoll. And that was when I got excited about remote sensing. Then I moved to Madison to work at the Environmental Remote Sensing Center, and we did have a handheld radiometer that we used to do upwelling and downwelling of radiance over the over water. Actually, we were doing a project where we were looking at lake clarity, and we wanted to have some in situ measurements. And we had a pretty expensive, fancy spectrometer with fiber optic leads, and it was pretty cool. I didn't actually use it at all, though. I was developing the website for it, so I never actually got to play with the instrument. And but I think I heard about the STELLA program through going to conferences and seeing the booth at various places. So I knew that in the back of my mind it was something I always wanted to do, and I thought, well, I'm never going to find the time to do it myself, but if I could get a couple of students who were interested, then I could supervise that and learn about it myself. So yeah, I think I learned as much as these two did. So yeah, thank you.
How did you first learn about the STELLA instrument and project?
Maybe I should start.
Okay.
So I think I saw a STELLA display at probably an America View conference. There was most recently that I made an impression on me was in Denver, and it was I think an ASPRS conference. And maybe, I don't know, you were, I'm pretty sure you were there, Michael.
Was I?
Yeah, or at least your booth was represented. There was a lot of kids groups coming through. It was Denver schools and stuff. At any rate, and I thought, I just think it's such a great idea to be able to build your own spectrometer and learn the principles of remote sensing with a hands-on tool like that. And so when I had the opportunity to create a couple positions in our summer internship program at Space Science and Engineering Center at UW-Madison, I signed up to sponsor one student. But when I got the resumes and the letters of interest, these two were tied for the best. So I decided I should just take on two instead of one. And one of the cool things was I saw they had different skill sets, and they taught each other during this process. So having two people was really great. I think Inna had some soldering skills, and Alexa had some 3D printing skills, and they shared those with each other. And now they both know how to do both. So yeah, pretty cool. And then I'll let them explain how they learned about it.
What initially drew you to integrate STELLA instruments into your educational programming?
Yeah, so Sam and I work on a project called America View. So a lot of states have their own Wisconsin View. So we're Wisconsin View, we're part of America View, and our mission is to empower, Earth observation through remote sensing. So we do a lot of satellite remote sensing, but at SSEC, we do some other ground-based remote sensing. But we, as the outreach person for Wisconsin View, wanted to come up with ways, not just to talk at students, but to let them actually get their hands on the science, which can be really hard to do with satellite data, just because you need some programming knowledge, just a lot of computational and technical background to actually play around with that. But with the Stellas, they could actually hold the instrument in their hands. You can't really do that with a satellite. So that was our main motivation, was how do we expand Wisconsin View's outreach efforts to continue giving students more of a hands-on experience with remote sensing concepts and remote sensing instruments with the STELLA.
What were your specific roles during your internship at the Space Science and Engineering Center?
Yeah, so Our main role, we worked through a lot of it together, and we essentially just took it step by step. I know Ina started her internship actually before me, so she started with actually ordering all the parts. So she technically did that all for me, which was great. So on my first day, we actually already had all the parts we needed. So that was pretty cool. And then from there, we essentially walked through, like we started with the Q2 since that was the simplest one. And our process is just going step by step, building our spectrometers, designing the case for the Q2, working on the 1.1. And then once we had all of that incorporated, then we got to do data, and then we got to programming so that we could actually, interpret that data. So it really changed from week to week, which was really cool because you got to test out so many new skills, and you weren't doing the same thing every day.
I came 2 weeks earlier before Alexa started her internship, and I just ordered parts. Everything else we did together, and especially Alexa was very helpful in debugging. Apparently, Alexa didn't mention, but some of her details, they were not working. And yeah, Alexa can go like over this, like why it didn't work. So yeah, we just had a lot of debugging as well. And maybe it would be nice, like write a small note for future people in case if they got into some like same troubles, they won't spend a lot of time. They will already like see the solution of this.
So excellent. And so to those different points, one thing, the experience of actually purchasing the parts, did you have any troubles there?
No,
Mm.
it's pretty much straightforward.
Okay.
I'll add that, as a university has pretty specific ways of buying things. And so we had to work with our purchasing department, and they showed us how to use that. We had to first demonstrate that we couldn't buy some of the parts from existing vendors that serve the university, but some of these are very specialized. And so we were able to justify using the sources that were possible for us to get all the parts. And then there were a couple of defective parts that had to be returned, and we went through a couple of cycles of that. But it was so it was part of the learning process, and I wanted Inna to experience that because that's real. Like when you're dealing within some sort of corporate structure or whatever, you have to follow the rules of the game, and sometimes it's inconvenient. But so that was part of the learning thing that maybe Alexa missed that, but that's okay. Alexa got involved in returning parts though, so I think you got you a suitable amount of red tape. That was good.
Was this your first dip into using the Stellas for teaching?
Yes, we had been wanting to use the Stellas for a while with Wisconsin View, and we, finally had enough money in our budget to hire engineering students to build them. So this was our first little foray into using the Stellas at all. So yeah, this was a rookie experience for me.
How would you describe the Stella project to someone unfamiliar with it, particularly from an educational perspective?
Yeah, that one's hard. I'm gonna have to think about it a little bit. The Stella experiment, well, I would definitely use the word remote sensing, and then depending on their background, we might have to explain what remote sensing is, which, I like to say is always exactly what it sounds like, sensing something from far away from a remote location. I really like the phrase that you just used, saying a spectral signature is kind of like a light fingerprint. I think that's a good way of explaining what a signature is. So each object has their own, special signature. Yeah, if they knew what the electromagnetic spectrum was, I would say that we've designed a handheld instrument that views the energy that an object gives off at different wavelengths and then relate wavelengths back to, the spectrum. Yeah, and then try to connect that with I guess I'm always trying to connect it back to like what I do, which is satellite stuff. So I would maybe show them or bring them an example of like a Landsat image and, move a cursor or my hand over different aspects of that Landsat image and say, each color or each different area has a spectral signature, and we can measure that from space or we can measure it from the ground. So we can do it like discretely with a STELLA if we were on the ground. But this Landsat image kind of does it all at once from space. I'd say that it's, a really good handheld, simple tool to use in the classroom that students can use with a little bit of instruction and inform them about different types of surfaces and properties and paying attention to detail and light and optics and how all of that relates. So I would hopefully say it a lot more eloquently than I just did. But yeah, I think something along those lines of a handheld instrument that students can use to get a taste of Earth observations using fundamental science and physics concepts, and adding in a little bit of optics science as well.
So yeah, and you mentioned like engineering students and all that. Can you tell me like, sort of like the overall structure of how you so you had some engineering students come in and build it and all that, and you had the students actually go and use it and all that. How was that whole system set up? Like, did you all do the purchasing? Did the students do the purchasing, all that sort of thing? And, basically from finish to end, what kind of system did you use to actually, make this a success?
Yeah, so Sam was their official like advisor, supervisor. So he might have a little bit more details about this, but basically we had them come in with maybe like a 10 or 8 week plan with different tasks to try to accomplish during that plan. There was of course some waiting time while parts came in, but the students came in, and then Alexa came in, and they learned about what parts they needed to order. So they placed an order for the parts through our purchasing office. And we have a great admin team that makes our life really, really easy. So our purchasing and financial staff was a big help here. Made sure that America View or Wisconsin View had all the funds to cover what they needed, which of course Sam and I had budgeted for. While they were waiting for the parts to come in, that was their time to do like a literature review and just learn more about remote sensing and the STELLA itself. At that point, excuse me, I had reached out to other America View members about what kind of curriculum they had done with the STELLA, because America View, we try to meet annually, and we have little poster sessions, and I had seen a poster on STELLA activities from Louisiana View. So I reached out to their staff and kind of asked them what they did in the classroom, to just start getting ideas of how we wanted to design our curriculum. So the Stellas were built. They got the parts, they built the instruments, they 3D printed all the cases and everything they needed, and then came time for like calibration and test measurements. I think it took, for a while, we only had 3 working machines, but Alexa Matson was able to get that all fixed up before our classroom experience. So yeah, I can't really go into further detail other than that. For the engineering details, you would have to ask Inna or Alexa M. but yeah, I met with them and wanted to know how many instruments we would have, how many would be functioning, so we knew how to split up the class. And I let them, know like the bones of the activity I wanted to do, but I asked them to like design a little worksheet with the tables that they would fill out and the graphs that they would plot. They already had a small presentation as part of their greater SSEC wrap-up presentation, so they kind of adapted that to a high school audience. We reviewed that and changed a couple of the details just so it would be easier for younger students to understand, relating it back to other applications such as, looking at celestial bodies and whatnot. So that was pretty much the layout of how it went. We did some prep work leading up to the actual classroom experience. They came in beforehand and just wanted to get an idea of like what the ambient light would look like in the classroom. So they came in a week prior just to get a feel of the space and how it would work. But they did a lot of the work themselves as far as like designing the worksheet under my guidance and having a plan of what we were actually going to be doing in the classroom.
Inna, could you walk us through the development process for the STELLA data analysis website?
Yeah, so this website I developed on my own because like this entire STELLA project was for organizing for high school kids like a lecture. They have like their like summer school, so we really needed like a tool which can very quickly analyze data and show students final result. And at first, we decided to use a Stella Data Viewer, but the problem is that it doesn't support the Stella Q2 version. So after this, we started to play around, like how still to make it possible. And at first, we thought just to write like own Python program, but it was not user friendly. So after this, we decided that maybe it's better just to make a website, and that's how we come out with this website. And it has, oh my god, it's so cute dog. Yeah, and we had two versions of the website, one with a graph, another one just with a table. And in the end, we decided just to use with a table as we wanted that kids could plot their graph on their own, on pencil and paper, not on like automatize everything, but also gives them opportunity to live in 21st century without all possible devices.
Alexa, what were the main challenges in designing the case modifications for the Q2?
Is making sure you're getting the exact correct dimension you need. There are times like I think my first case came out as like by some miracle all of it fit except for the microprocessor, which like the alignment holes were just like 2 millimeters off. So that's a lot of the struggle in it is just making sure it's very exact. And then on top of that, just making sure that it holds up well, that you're able to click it on and off. You're able to take it apart and do that multiple times, so you don't have to be worried about it breaking. And then I played around with, I had an SD panel on the back, and I was playing around with having to decide that because I hadn't designed that before, and I ended up I was using my mouse. On the back of my mouse, there's the removable panel where the battery is, and I remember like I kept taking it on and off, trying to figure out how they designed it so it works, and then I kind of just played around with it on my own to make that part. So it was a really fun challenge, and there's a lot of detail in it, but it just made it, when it finally came out right, that much more satisfying.
Inna, could you explain the technical differences between the first and simplified versions of the data analysis website?
Yeah, the difference just for the first version, you can see a graph. For the second version, there is no graph. There is just a table with data. And yeah, as I explained before, we need this because we wanted students to work with pencil and paper to draw themselves these graphs.
And then what programming languages and tools did you use in developing the web interface?
Yeah, I use just Python. They have such nice library as Flask. It's very nice library because you can combine HTML website, like how it looks, also with CSS, like how exactly you want your like all your buttons work, and you can also program on your own some functions. For example, in our case, we can extract some data from the spreadsheet, but we need then calculate what would be like the final irradiance. So the final reflectancy, sorry. So I just used HTML, like Python and CSS.
Well, I was approached by our center leadership to help run the program this summer with a colleague, Dave Hayes, and so one of the things that we did was we had all of the interns. There were about between 10 and 12 throughout the summer, meet once a week at a roundtable discussion and go around the table, and the students would update on the various projects they were working on. And I was fortunate because I had a project and I was in that room every week, so I would get the update from both and Alexa, as well as hear about all the other projects. And then we would touch base after the meeting to talk about any issues or requirements. I leaned heavily on my colleagues to help. Our fifth floor of our building is kind of where hardware is created, where they developed the scanning his spectrometer and sounder for satellites. So there's actually a whole clean room and a lot of high-end technology and people who know how to do all of that stuff. And so we were lucky that Rob Lemke, one of my colleagues, was willing and able to help get the workspaces set up with anti-static mats and soldering setups for both. And I think probably provided some instruction on that too. Also provided the multimeter that Alexa talked about needing for, and then so yeah, I had buy-in from people on colleagues who work in the area of instrumentation, which I don't. I'm more of a visualization person, so I needed that help from my colleagues. But so I think that the two things were having regular meetings and then making sure connecting Alexa and with the people who could answer their questions or help. And fortunately, both of these students are so they're self-starters and didn't require a lot of micromanaging at all. And I prefer that style. I prefer saying, okay, you can figure it out and tell me when you do, and if you can't, then tell me and we'll find someone who can help, So that was just kind of how we did it.
Not the development. What inspired you to use the spectroscopic mystery activity, and how did it go?
We were looking at the activities that were on the website, and that sounded really fun, and thought I got across the different how to read graphs and how light works and how you can read reflectance to see the color of things. And on top of that, mysteries are fun. I feel like kids can connect with that and get that hands-on experience with what we built. And yeah.
So can you describe like what your setup was for the mystery, what you all did, what you all found useful, so on and so forth?
Yeah. So spectropic mystery is pretty much where you have the kids take their own spectral measurements using the spectrometers of a variety of different materials. And then you can put up different spectral graphs, and they get to identify which one they think it is based on their own measurements. And yeah, so when we did it, I believe we had a couple different things. We had healthy leaves. We tried to get brown leaves or decaying leaves. And we had like folders, notebooks. What else? Am I forgetting something?
3D printed cases, which
Yeah.
which failed.
Yeah. Our first drafts of our 3D printed cases we reused as measurements because they're black and white. So we tried to get things of a variety of colors too. And it was a lot of fun. We had 4 working spectrometers that we had the kids then split up into 4 groups, and each group got their own spectrometer, and it worked really well.
Yeah, so the lab was basically set up so that we had different materials, different surfaces, and the kids were given a little demo of how to use the spectrometers. I think it was a little hard for them to pick up on at first. We had 4 instruments and we split up in like 4 groups of 2 or 3, I think was how we set it up. So we took in one group at a time and we just had them stand around a table, and then we did a demo of this is how you use the instrument. Usually we did sandwich observations, so we do a calibration reading and then a reading of the object and then a calibration reading. So that was a little hard to drill in. You know, they're used to just like pointing and clicking and having it be that easy, but it's a little bit more complicated than that. So we went around and did that one group at a time and then gave them the rest of the materials. We had a list of materials that they had to measure. So one was like a healthy leaf, a dying leaf, and then things that we just found around the office. So like red binder, orange binder, black case, white case, just random things that we could get our hands on. And they took measurements of each of those. And then, it was a little hard teaching them all how to use the instrument. I couldn't teach them all how to use the instrument as a class. So we broke up into those subgroups and I just taught like 2 or 3 students at a time so they could actually see us clicking the buttons and holding the instruments. And they were a little confused with how they were actually going to get the data because we had to use data readers to get the information off the machine after all the measurements had been taken. So what they did was they did like calibration, measurement, calibration, and then they wrote down batch numbers to reference. And they were like, why are we writing down these batch numbers instead of writing down data? So maybe we could have done a better job explaining that. But afterwards, we gave them SD readers that they could plug into their laptops. Each student had a laptop. We took the SD readers out of the STELLAs, and then one of the engineering students wrote a really easy, she coded up a website so that they could extract the data pretty easily. So after they got the data, they had these tables that was just like wavelength versus reflectance. And so they wrote down each wavelength and they wrote down each reflectance. And then with that data, they had to draw like an XY graph of the pattern of reflectance versus, or wavelength versus reflectance. So it was a lot of steps to get to the end product, and we ended up not having enough time because they were learning a lot all at once. But it was a really good experience. I think they still took away some knowledge from it. We had some issues with the data not reading incorrectly, like we were getting, I don't know, numbers in the thousands for reflectance, which, you know, doesn't make sense because we're supposed to be between 0 and 1. So we had some issues reading in the data where they just had to do the step over again to get their valid data. And yeah, we had a couple students resulting in trends that actually made sense. So what we were planning on doing was showing the shapes of wavelength versus reflection up on the board and saying, you know, guess which object this is based on the shape. And then kind of explaining like, oh, this is more reflective in the green channel because et cetera, or this is more reflective in red because it's close to the infrared, which has to do with heat. So, you know, that's why the number goes up there. Yeah, we were a little bit rushed at the end. We did run out of time. And since we ran out of time, a lot of the kids didn't get to draw their XY plots all the way. So I think we only had one group with one object came out with it like correctly.
Oh yeah.
So yeah, I would probably better control for time next time and just come up with a better way to communicate what they were supposed to do with the time given. But it was still really fun. I think the students had a good time and walked away with something. So I consider that mission accomplished.
Areas where you had issues. Can you describe what issues you all ran into? And this goes for both or all three of you, really.
So, well, with my Q2 at least, I had a problem with the LED button, which ended up being a very simple fix. It was just we had to return it and get a new one. But beforehand, it was troubleshooting to make sure that that was the actual problem. So we used a multimeter to see if voltage was actually getting through, and it wasn't. And then it was nice having a second person because then I actually was able to take the button off the second Q2 and then put it on mine to make sure that it was actually the button and it worked. So we could be like, okay, this is definitely the issue. And then we went through the return process and luckily the new one worked. And then a bit of, I guess, I also had a sensor, I believe it was the Vis spectral sensor on the 1.1 that didn't connect, it wouldn't connect to the I2C bus for whatever reason. And it was getting voltage, a light was blinking on it, but again, it was nice to compare to Inna's because I could see that mine just continued blinking while hers would turn on and off and hers was working. So I couldn't find anything wrong with it. It just wasn't showing up when I did the test codes. And so that's kind of where I had to do research and see if other people had this problem. And other people did have this problem. And apparently it was a somewhat common issue with this specific sensor. So then I had to go through the return process again. I got a second one, but it was from the same batch. So the second one was also faulty. And then it took a few weeks to get the third one, which finally did work. So it was a much longer process. Technically, the spectrometer worked in that time. It just couldn't actually read visible light, which was a little unfortunate. But when I finally did get it, it was very satisfying. And then, yeah.
That was also a sensor that was soldered on too, right? So this wasn't just a matter of plugging it and unplugging it each time.
Yes.
So this was one of the more complicated issues.
Yeah. Well, I learned my lesson the first time because I had soldered it on and tested it and realized it didn't work. So then for the next two sensors, because desoldering is a whole process. I have my own like Arduino control board, and then I just used my own breadboard and tested it on there before soldering it, which made my life a whole lot easier. So that was a good lesson to learn.
Excellent. Anyone else any troubles that weren't mentioned?
Thanks God, no. I just had at first some troubles with screen, but it was just I just had the wrong wiring at first, but then it worked. So
there was also the first 3D printing of the case for the Q2. The battery didn't fit, so we had to redesign the case for the Q2 to fit the battery that was on that we had ordered.
What was the most challenging technical obstacle you encountered, and how did you overcome it? And this can go not only just to the web interface, but to the STELLA itself. Was it the chips? Was it the the redesign of the case? What do you think was the most challenging?
I remember building the 1.1 was really cool, but also very stressful because you're soldering wires and resistors and capacitors, and you're so worried that you're going to put it in the wrong place, and then like desoldering is a pain. So I think that was really cool, but definitely just going through it and going through every step and like triple checking yourself was really hard. I remember the wiring on the actual display screen, I think, was the most difficult part because you have to go through the holes and then do all that. I think at one point I switched 2 wires around and my display wasn't working, and then I realized I did that, and it was easier to actually because they're colored to what the directions had said to make it easier to identify. And I think I switched the colors because it was just easier to swap the ends than to actually make them the right colors that it was. So that part was very technically difficult, but it also practiced a lot of skills in soldering and accuracy, and yeah.
Excellent. What about you? For you, Inna, what was the most
yeah,
challenging?
absolutely same. Absolutely same. It was just about like checking everything like several times, making sure that that's how it's supposed to be.
What would you change or improve about STELLA based on your experience?
Oh, for me, like for Stella 1.1, I would like to have this inlight, which you had for Stella Q2. It's so convenient when you can just hold the device just in front of the object which you want to detect. And the second thing, I really liked the touch screen which you have on Stella 1.1. It would be amazing if you could put this on Stella Q2, and you can read at the same time when you're taking your data, you can read what's your data points to make sure that you're like really taking data.
Excellent.
I think you mentioned this before with the 1.2, but I think having the troubleshooting as you go is a huge help. Just because when you're working with so many sensors and one doesn't work, I think that would be a huge benefit. But otherwise, I completely agree with the light on the Q2 was great, especially for taking like measurements on leaves. So yeah, I think that would be it.
How did the hands-on nature of STELLA work affect their ability to ask good scientific questions? Now, I know you said there's only 2 days, so they might not have really asked that many, but it's worth a shot in the dark.
I think that it really challenged them to improve their technical language. STELLA was really the only like lab experience that we got to do in class, because a lot of it, like we do a lot of touring of the campus and visiting museums and hearing from guest lectures. We did do a lot of programming the first week, so I guess you could kind of consider that like computer lab time. But as far as like a traditional lab experience that I think of, STELLA was the only one that we did. So I think it challenged them to, when asking clarifying questions of how do I get this to work? How do I upload my data? Like what exactly is the purpose of writing down these batch numbers? I think it allowed them to improve their technical communication just by elaborating more on like what exactly are we doing here, because yeah, like I said, we probably could have communicated like the goal and the steps a little bit more clearly to them. Yeah, so just following up and figuring out like what is the purpose of what we're even doing. I think it made them a little bit more comfortable asking those questions and yeah, phrasing things in a technical way that their instructors and helpers could understand and better answer their questions.
How did this experience differ from typical classroom or laboratory learning?
Well, I can tell that for me the difference was, um, first of all, you don't have like any like deadlines, and of course you have like some like set up like time when you need to do, but you don't have pressure about the deadline, so you just doing this stuff, and you can really just enjoy the process when you're doing. And the second thing which was for me different is that it's more like a teamwork. It's not just assignment which just you have. You can work with a team. You can ask different type of people about how to debug something. As Sam told, we had his colleague Robert Lemke. He helped us very like so much in electrical engineering. So you can just expand your network with other people and just enjoy and learn new skills.
Excellent.
Yeah, I completely agree with, it's very different in the way that it's very flexible. You're making a lot of choices and designs yourself, and that's really cool. You're given essentially a goal, but how you get there you can vary, and that's a really cool process. And even coding and deciding how you want your graphs to look and figuring out how you want to take the data from the spectrometer and how you want it to turn out. It's just, it is really, really, it's really cool to just have so much control over that. And then also just be able to problem solve yourself and work with a partner and kind of see it applied to the real world.
What new skills did you develop through your work with STELLA that you hadn't anticipated?
I think for me, I got to get a lot of practice with soldering with Inna's help, which was great. I also got to I got to learn a lot of troubleshooting with the electronics, with the problems I ran into, which is a very helpful skill. And then on top of that, just the trying to come up with how to present the spectrometers to a group of students in a way that they can understand, and how to use them and how to read them. That was a fun challenge.
Excellent.
Yeah. For me, like before I was usually using like Fusion 360 for 3D modeling, and for this project it was my first time when I used SolidWorks for 3D modeling. Also, it was very interesting to explain about the spectrometer also to my family, not only to kids, because before I was preparing to explain this to my parents and my sisters, and it was very, very interesting conversation. Yeah, because they're doing biology. That's why, like, my mom is teacher of biology and chemistry, and she asked me a lot of questions, like how exactly will it impact to my work? Like, how can I explain this to my students? It was interesting.
Based upon your experience, you said you would like a little bit more time. What kind of teaching strategies do you think worked well, and which kinds do you think didn't work quite so well? You know,
I think that hands-on learning supplemented with visual material always works really well in the classroom, because at that age, I don't really like talking at them for more than maybe 10 minutes. Like, I think if we have guest lectures, they'll sometimes go 30 minutes, but if we talk and then do something and then talk and then do something, that is the best way for them to learn, because I think they can really tune out easily otherwise. So yeah, I think I would definitely break up lecture material and any like audio and visual learning with an activity or a hands-on example, um, in order for the material to really sink in better.
and what advice would you give to other educators wanting to implement similar programs?
I would say that it's probably a good idea to do like a dress rehearsal, so to speak. Just do a dry run of exactly how you're going to teach the students. And one thing that was kind of a hiccup in our class was that when we were teaching each subgroup how to use the instruments, the other groups were just kind of like sitting and waiting around. It didn't have like a lot to do. So I would maybe come up with some sort of activity, like where while we're teaching one subgroup how to use the instruments and take a reading, the other subgroups can have a collection of materials and kind of take those field notes that we were talking about. So just writing down observations that they're making about the materials that they are planning on measuring with the stellas. So writing about color, texture, surfaces, things like that. I think that would be kind of a good filler activity, so they're not just like waiting around, waiting to take their turn.
What aspects of this work do you find most rewarding from an educator's perspective?
Yeah, I think the most rewarding part is when the students get a result that makes sense to them and looks correct. So we had one group, draw the actual spectrum line, and the shape matched what it was supposed to look like. And this is the first time they'd ever done this, so they drew their line and made their points, and they showed it to me and Inna and Alexa, and they were like, is this right? And we were so excited because they had gotten it right. We were like, yeah, you did it. And they were kind of confused as to like the fact that they got it right. And so we had to like kind of amp them up and be like, yeah, you actually did it correctly. Like, you did what you were supposed to do. So I think that's the most rewarding, is kind of cheering them on and like, yeah, telling them that they did the activity correctly. And then, of course, relating in the end back to like why that mattered and why, like what they should have taken away from it. I think when they get the right answer on their own, it can be really, really satisfying, when they're excited about it. I think in this case, they were like confused as to why they should be excited about it, and we had to like tell them why it was exciting. But yeah, I think if we had done a better job of just the logistics of the classroom, then we could have had more of that like satisfying experience of the students like being really excited that they had gotten to the correct answer, or they had gotten something to work.
How do you see Stella evolving as an educational tool in the coming years? I'll go with Dr. Sam first for this one.
Well, this was such a good experience. I could see doing this each year with and just building on the results of this group. I might take on another intern or two next summer and have them do whatever the next model is of Stella, and then build on what Inna and Alexa have done. But also, I think, I'd love to see. So I work mostly with atmospheric scientists and meteorologists, and so land remote sensing is more my background, and I'd like to make sure my colleagues know more about that, because we're starting to use weather satellites to look at things like fire and smoke and things that are related to land processes. So I kind of see it professionally actually helping educate my own colleagues too. So I think it could be kind of I could imagine growing this program within my own work.
Okay, how much your contributions to help expand Stella's reach? Help expand Stella's reach to more student populations, more different student populations. Did you get the question?
I think so. I think so. This would probably be a good one for Alexa Ross, but I can just say that through America View program, we've learned that one of the best ways to grow curriculum or our outreach is by teaching teachers. And so if we can have summer workshops where we could work with teachers, then they can take it into their classrooms. And that's kind of a way to, an avenue for expanding. But I think Alexa Ross has pretty good connections within the Madison community here in Madison, Wisconsin. And I believe that she has got plans for expanding curriculum and using these tools.
So you worked with Inna and Alexa. What changes did you observe in Inna and Alexa's engagement and enthusiasm for STEM learning throughout their Stella experience?
Yeah, I didn't really work. I worked with them closely towards the end when we were ready to implement everything they had done into classroom curriculum. But for the most part, they were just really good at self-starting, and we gave them like a schedule of like week 1 you should do this, week 2 do this, and they didn't really need much oversight at all. They knew the mission. They were really efficient at finding what they needed to find. I think it was helpful because Alexa Matson was a UW is a UW engineering student, so she already had knowledge of things like where to find the 3D printer and how to get into that maker space and design and print what they needed. So that was really helpful. I think that I was really impressed at the end with their ability to communicate to the students, not only the background of what like spectroscopy is, but when they were teaching the students how to use the instruments, just their communication skills. Because I didn't interact with them a ton leading up to this. And Inna especially seemed a little quiet, so I wasn't sure how she was going to do like presenting to students, because you have to speak loudly. There are these loud ventilators in the back of the classroom, so sometimes it's hard to hear, but they did a really great job. So I was impressed in the end by their science communication skills. And I know that they also had to do like an internal SSEC presentation that all of our student undergraduate interns have to do. So I think maybe if they had been like preparing or practicing for that, it helped. But they did a great job in the end in the classroom. And yeah, so I was impressed by their science communication skills, both presenting in front of the class, but also just working one-on-one with the students who needed a little bit of help on how to take the measurements correctly and then how to extract the data from the SD cards. They were really willing to sit down and troubleshoot with a student and work with them one-on-one to accomplish their tasks and goals.
What's the most important thing you want people to know about your STELLA project?
It was such a fun and educational project. I had so much fun this summer doing it that it didn't even feel like a job. It genuinely all the different skills I got to learn from week to week, and just the way it was so different from week to week was really great. And it's just the variety of things you get to do. I didn't realize it till we did like our final presentation at the end, or even like putting that presentation together, is just how much stuff we were able to do. And that was so cool because it was only 10 weeks. And it didn't feel like 10 weeks. So yeah.
Excellent.
Yeah, for me, STELLA it's also like about like be confident about that I really like engineering and I want to continue doing engineering, and it's also like about like you are working with many fields, as Alexa mentioned. That's why you can combine your programming skills, like your like soldering, like everything, and just enjoy the process, and don't be like pressured that it's something super difficult. It's not. Like everything is in Google or ChatGPT, so you can just ask them and they will answer you.
Excellent.
I think the memorable thing for me is is just watching these two students teach each other things and learn from each other, and I think the Stella is in this kind of it's almost like a catalyst for learning. It makes a lot of learning happen, and it's all centered around this device, but like Alexa pointed out, it crosses all these boundaries into other disciplines and other topics, and so it's I think of it almost like the spokes of a wheel. It's like this Stella can be the hub in the middle, and there's all of these topics and possible questions and things to explore that radiate out from that. And so it was just really a pleasure to work on this project.
How has working with STELLA changed your perspective on NASA technology or space science, or just the remote sensing and all that? So how has it changed your perspective basically on the various technologies that are out there?
I can tell that for me, I always thought that NASA is something so far from me that I maybe can access to this only after getting PhD. But this summer I found out that you don't have to finish a PhD to work with some NASA materials. You can be even a high school kid. It's open source, and you can do it even from your home, and it doesn't require some like super expensive equipment. You can just buy it on DigiKey or Amazon and build on your own.
I think for me, the part of the NASA I was focused on was the like other planets and space aspect of it, and getting to work spectrometers, and also learning about how it can be used to track wildfires, vegetation health, and all these different applications just on Earth was really cool. And then having also the ability to build an instrument that's not super expensive, that's super simple to use, to actually see that on a smaller scale was really cool.
What surprised you most about working with Stella technology? And again, this goes to anyone.
Well, for me, it was really surprising. Like in the end, when we were comparing our data with Landsat data, we had the satellite. I forgot the name. Was the Lancet, right? Yeah, so when we were comparing results with the Lancet, I was surprised when our results got really like they were very, very close. And that's why I was really surprised that like this like very cheap machine like can take same result as something that is in like in space, which is like very, very far away. And I had feeling like I touched something like something super like something unusual.
I think that thing that was I was surprised how I wasn't sure what to expect, honestly, with like were we going to be able to get all the parts we needed? You know, I mean, at the beginning of this, I really wasn't sure if we were, you know, the goal was to make 4 spectrometers, but I had no idea if it was really going to happen or not. You know, we had 10 weeks and we had all these other goals like, okay. And so I think, you know, we got the parts, took about a week. We got and then they built them so quickly that we had plenty of time to work on other things, which was so great. And basically every time we met, it was kind of like, okay, what are we going to do next? You know, like, and so I guess for me, it just what was surprising about the whole program is how it kind of there was kind of a feedback loop and almost a snowballing effect where it got better and better as we went along because we got to do more and learn more and discover as we went. So I think I thought it was just going to be making spectrometers, honestly. I didn't think we were going to do everything else that we ended up doing.
Excellent. And Alexa?
I think what surprised me the most was just how much you could do with the spectrometers and what kind of different experiments you can use them for. Because there's so much more even than what we did. I know one of the things I ended up doing was I collected a variety of leaves and then I left them on my desk for like a week. And then I compared the spectral measurements of when I first got them and then a week later, which is really cool because then you get to see the drop in the infrared and then the absorption and like the blue and red parts of the spectrum on the graph. And it was cool to physically see that just on something I left on my desk for a week. But even that, like when I went through the GitHub on some of the suggestions of different experiments, there's so much that you can do, and there's so much you can learn, just like with any spectrometer.
Excellent. Now, quick question: Did you use a any kind of weight reference to normalize your? Okay. What did you all use? What was your?
We essentially took a piece of construction paper and we taped it to a box so that when we were outside, then it could just sit on the grass, and then we took calibration measurements from it.